In the last video, we have seen how to use a method which is for each to print all the values of list. So what we have done so far is we have created a list of values in which I have assigned 6 values. So in order to assign values, we can use two ways. Either we can create an object of array list and then we can add values. Otherwise, if you know the values at the start, you can use a class called as arrays dot asList method to assign all the values. This method in turns give you object of array list. So once you got the object with 6 elements, to print these values, we can use external iterations that we have done in the previous video. Like you can use a for loop, you can use enhanced for loop, or you can use something called as iterator. Otherwise, you can go with internal iterations using this for each method. So for each method here gives you internal iterations using which you can fetch one value and print that value. So we are taking the value and printing it. We are not doing any extra things here. Now, then you will say, okay, what is this arrow here? So as we have seen in the last video, this arrow means Lambda expression. So if you have an interface with only one method, so instead of creating the object, you can directly use a Lambda expression here. So when you talk about this for each method needs an object of consumer that we have seen in the last video. So what we'll do is we'll see that method one more time. So we have returned for each new. We can do in this way also. We can say consumer. We can create an anonymous class here. And this consumer, we can create, we have to specify the type of element. So in this consumer, we have to specify all these values are integers. And since consumer is an interface, you can go to this. Let me just first import the package. So if you go to this consumer interface now, it is written it's a functional interface. Now this functional interface, if you remember in 1.7 or 1.6, if you are using any version before 1.8, interface were of 3 types. First is normal interface, interface with multiple methods. Then we used to have marker interface, which is an interface without any method. And then now we have this SAM interface. Now SAM stands for it is single abstract method interface, which simply means you have only one method in that interface. In this scenario, in 1.8, all your SAM interfaces, which is single abstract method interfaces, are called as functional interface. So what is functional interface? It's the interface with only one method declared. Clear? So you can also define functional interface with the help of this at functional interface annotations. Okay. So if we talk about this consumer interface, it has only one method. So we need to define that method here. So we'll say public void accept, and the value, the type of parameter it will take is integer I, and we can simply print the value of I. Right? So if you use this thing, it will do the same thing, or if you write this thing, it will do the same thing. If I comment this part and if I run this code now, it will still work. So if I run this, and you can see the output here, it will take some time. Come on fast. Yeah. So you can see the output is 1, 2, 3, 4, 5, 6. It's because we have used a method here which is a for each method which prints all the values. So if we talk about here for each method, it's only take the object of consumer interface. Now if we talk about this consumer interface, it's a functional interface. So Java 1.8 says if you have a functional interface with only one method, so this type of code here is called as boilerplate code, which simply means this for each method only takes the object of consumer. So why we need to write this thing? So we can remove this part. Since we have removed that curly braces, we have to remove this one also. Now since that object there, which is consumer, has only one method which is accept, so why to write this part? Right? So the only thing we have to specify here is only I, right, which is the variable name. Why to specify this type when you know all the elements are integer? So we can remove this also. And then we can specify our arrow saying there's a method called as public void accept which takes a parameter int integer I and this is the code for that. So indirectly, this code represents public or new consumer, public void accept integer I, and in bracket you have this. But since you have only one statement here, we don't have to specify a semicolon and a curly braces. So you can simply write this one. Now, in turn, if you write this command, this is same like this one, right? So if you compare these two statements here, they are same. So what we can do, we can remove the comment and we can remove this part, and still the output is, if I run this, the output is same. You can see the output is same, right? Now that means, can I use a Lambda expression for all the interface? No, Lambda expression only works with functional interfaces. So if you have any interface which is not functional, Lambda expression will not work. Clear? So this is how we need to use Lambda expression. So in the next video, we'll talk more about other methods of Stream API.